When you've got continuous data and it's grouped, histograms can be a great choice, and we're looking at them today. A histogram is similar to a bar chart, but there are a few key differences. Histograms must always use a continuous measurement for the x-axis, such as length. Also on a bar chart, the height is the frequency, yet in a histogram, frequency is shown by the bar's area. The height represents what we call the frequency density. Frequency density is proportional to frequency over class width. We usually use a constant of proportionality of 1, so frequency density will equal frequency over class width, but be careful with this. To find the frequency of this bar, we can multiply the class width by the frequency density. The class width is the width of the bar, so 3. The frequency density is the height, so 5. If the frequency density is not labelled, you can just count the squares and use that. The frequency will therefore be 3 times 5, which is 15, assuming that the constant of proportionality is 1. If the question states that the frequency is actually 30, then you know you'll need to double each of the areas of the bars. Let's have a go at these questions. We're asked to explain why a histogram is suitable for this data. A histogram is suitable because the length is continuous and we have the data in a grouped frequency table. In this question we're asked to draw a histogram for the data in the table. We need to start by finding the class widths. We can subtract the bounds for each group. So the first group is 0 to 2, so 2 take away 0 is 2. The next one, 5 take away 2, 3. 5.5 take away 5 is 0.5. 8.5 take away 5 is 3, and then 14 take away 8.5 is 5.5. We can then divide the frequency by the class width to find the frequency density. So we're going to do 3 divided by 2, 1.5, 12 divided by 3 is 4, 4 divided by 0.5, 8, 30 divided by 3 is 10, and 11 divided by 5.5, which is 2. We can then draw a histogram. In this question we're asked to estimate the number of worms between 7 centimeters and 12 centimeters. To find the frequency between 7 and 12, we can draw lines up from 7 and 12 and find the areas of all the rectangles between these two lines. We have 2 rectangles between these two lines, so we need to multiply the heights and the widths of each rectangle to find the frequencies of each. So 10 times 1.5, which is 15, and then 3.5 times 2, which is 7. 15 plus 7 is 22. So there are approximately 22 worms between 7 centimeters and 12 centimeters. And let's finish with this. A table has the groups 1 to 3, 4 to 8, and 9 to 12, and a histogram is drawn. Find the class boundaries for the second bar. If you know, write it in the comments below. And you can come to onmaths.com or click the link in the description to access all of our free A-level papers and predictions, and you can even save your scores with a free account. This video is part of a larger A-level course that you can follow along with at onmaths.com.